Okay, so we are going to do the introduction to organic chemistry. And so this I find is very important. So we're going to go over it very slowly and with a lot of repetition so that as we as we go through it and help you understand it, it will hopefully get better because the basics of organic chemistry is very important because of course it helps you into as you get more complex in the section. And of course, you're going to be referring to a lot of other sections that you've done, so it's all intertwined, of course. So let's start off with the definition of organic chemistry, and it is the study of carbon containing compounds. Okay, next slide. So we have our introduction. So of course, there are nearly over 10 million carbon compounds that exist. So that's about 95% of all compounds. So that's a lot of carbon compound materials. So as we know, living things are made of atoms that are covalently bonded to form molecules of organic compounds. And so when I mean covalently bonded, I'm talking about, in your section with chemical bonding, with your different bonds like metallic, ionic, and covalent. And so remember your covalent bonding, very important for organic chemistry. Okay, so we know that every carbon atom can bond with other carbon atoms to form chains and rings. And so specifically a carbon atom can form long chains, okay? And we're going to go into this further detail. So organic compounds may also contain well, these chains and rings that carbon atoms form can be bonded to other atoms of other elements like hydrogen, oxygen, nitrogen, sulfur, and your halogens. Remember that group in the periodic table? So, but we need to remember that not all carbon compounds are classified as organic compounds. So these are called inorganic compounds. And examples of this would be the oxides of carbon compounds like your carbon dioxide, your diamonds, your graphite, your carbonates, your carbides, and cyanides. Okay, so now why is carbon so important as a building block in organic chemistry? So remember that carbon has a valency of 4 electrons. So of course, when I mean valency, I'm talking about my outer electrons, right? So sorry, just getting my pen. So we have our carbon atom here. And I'm talking about my 4 valence electrons. So I have four outer electrons. So that means that 4 bonds can be formed with carbon. So I mean, okay, so in terms of this, we have our 4, and for example, I'm just going to be using single bonds. So here I have a hydrogen, maybe an oxygen here, maybe a hydrogen at the end being formed there, and another hydrogen. And then what's really cool about this is that that specific hydrogen can form, you know, other bonds. Okay, let's say this is carbon. Okay, where's my eraser? Okay, so for example, this can also bond to another carbon, and then so forth can bond to another carbon with hydrogen or another carbon, and the possibilities are endless. So that's why it forms such a long chain, for example. Okay, so remember, very important, 4 valence electrons carbon has, so that means 4 different bonds can be formed. And remember, it goes back to the bonds of the elements of hydrogen, oxygen, nitrogen, sulfur, and your halogens. Very important to remember. So, one thing that we call carbon, okay, so since carbon has such a small atomic size, it can form stable covalent bonds which means that carbon is tetravalent, so tetra 4. And so these bonds that carbon forms, we know as single bonds, we know as double or triple bonds. So this is very important. So it can form different covalent bonds, which are single, double, or triple. So we need to remember that carbon always needs 4 bonds in order to have enough electrons to fill its outermost energy level, so its valence electron level. And then we need to also remember that similarly, hydrogen will only ever form 1 bond and oxygen will only form 2 bonds. So those are very important points to remember. And the reason why I keep repeating this about the outer electrons is because remember in your chemical bonding section, we need to know this, as even in organic chemistry, bonds are forming, bonds are breaking, so we need to understand chemical bonding. Okay, so okay. Now in organic chemistry, there are 2 very important concepts which are definitions that we need to understand, and you're going to be using this a lot. So the first one is functional groups. So these are groups of atoms within the molecule which determine the chemical properties of a molecule. So a functional example of a functional group, could be a double bond. So we have our, no, okay, sorry. So we have our C and we have a double bond. So all the molecules that have a double bond with carbon form into a functional group. So as I said, a double bond, a hydroxyl group, a carbonyl group. So those are your functional groups. And then the next important definition, oops, wrote on that, let me just erase that. Okay, is your homologous series. And these are a family of compounds containing the same functional groups. So 2 very important definitions and concepts you need to remember in this section. So, as we know, now we're going to go into the basics of the simplest organic compounds. And these are your hydrocarbons. So they are the simplest group of organic compounds that contain only hydrogen and carbon. So they're only bonded to so carbon is only bonded to hydrogen atoms. And so, for example, in hydrocarbons, you're going to have 3 different homologous series, the classes of compounds, in a hydrocarbon. And then these will be your alkanes, alkenes, and your oops, sorry. And your well, we're only going to be focusing on your alkanes and alkenes. We don't need to know your alkynes just yet. Okay. So now with alkanes, there are hydrocarbons where the bonds between the carbons are all single bonds. So when I'm talking about single bonds, I'm meaning only one line. So this is a single bond, okay? And then your alkenes are hydrocarbons with at least one carbon-carbon double bond. So this is what they would look like with the alkenes. Okay. So now we're going to go into a very important section with naming organic compounds. And so we're going to start only with alkanes at the moment, because very important, because then it builds into your different compounds. So as we know, naming of organic compounds, we use the IUPAC system, so nomenclature. So that's another word for naming of organic compounds. Okay, so when it comes to organic compounds, the first thing you need to remember is your prefixes so these will be the first word in your organic compound. And so we always use these to indicate how many carbons they are in the longest chain. So of course we have, if there's only 1 carbon, we use meth. If there's 2 carbons, we use eth. If there's 3, we use prop. If there's 4, we use but. If 5, we use pent. 6 hex, 7 hept, 8 oct, 9 non, 10 dec. Okay, so remember, so for example, as I said, carbons can form long chains. So let's say, and we're doing alkanes, so we're just using these single bonds. So for example, I'm going to go 1, 2, 3, 4, 5. So I see 5 carbon bonds in my chain. So then I'm going to go to pent. So it's going to be something with, so it's going to start off with pent. Okay. And then the second rule you need to learn is your suffixes. So these are used to indicate whether your compound is an alkane or an alkene. So you need to, the reason why we use alkane or alkene is to say whether it's a single bond or a double bond. Okay? So alkanes will have the suffix ane. So remember, it's in the name ane, alkanes. And then your alkenes will have the suffix ene. So remember alkenes, okay? Good. So now let's go into a bit of information about alkanes, so which will help us. Okay, so alkanes have only single bonds, as we said. So the general formula for all alkanes is CnH2n plus 2. Now, when we mean about a general formula, we use this to name things, okay? To calculate what your formula will be when we're naming compounds, because every compound name has to have a formula, right? Okay, so for example, you would use, for example, let's say we're using 5 carbons, and remember, that is pent. So we're going to go C5, and remember, we're going to have our hydrogens bonded to it because carbon has 2 hydrogens, and the terminal carbons, so the carbons at each end of your chain, have 1 more carbon, okay? Let me say that statement again. So alkanes have only 1 single bond. The general formula for all alkanes is this, and this is because every carbon has 2 hydrogens, and the terminal carbons, so the carbons on each end of the chain, have 1 more carbon. Okay, so how's this going to work? So let's say I have 5 carbons, so then I automatically have my 2 hydrogens, and then I replace, remember, my N is 5, and then I'm going to plus 2. So when I have 5 carbons, I need to have, okay, so we have 2 times 5, which is 10, plus 2, 12 hydrogens, okay? So let me make this smaller so we can fit it all onto the screen. Okay, so let me show you how, at the moment, this is going to be the layout to show you how this will work. Okay, let me do it in a different color. Okay, so I have my 5 carbons. So I'm going to go 1, 2, 3, 4, 5. Now remember, an alkane has a single bond. So then I'm going to put all my single bonds in first. And then I'm going to put my hydrogen bonds in. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you see how that works? How the math makes sense in that terms? Because as we said, how each terminal carbon, the one on each of the carbon, have 1 more. Sorry, it wouldn't be 1 more carbon, it would be hydrogen, sorry. So that's a hydrogen. So so you see your middle carbons only have 2 because it's bonding with only 1 hydrogen atom, another hydrogen atom, a carbon atom, and a carbon atom. So when you get to your end, your carbons at the end of the chain, you are only bonding with 1 carbon, so that leaves you to bond with 3 hydrogens. Okay, good. So now, let us go through in terms of our our prefixes and how it's going to go with our suffixes, okay? So now I've got the first 5 alkanes, okay? Just so I can just show you with their formula. Okay, so remember we have our formula of CnH2n H2N plus 2. Okay, so for example, methane. So meth is 1 carbon, and remember, so that gives carbon the opportunity to bond with 4 hydrogens. Okay, so we have our meth, which is your prefix, and ane, remember, because we're dealing with an alkane, because you see single bonds only. So in terms of to calculate, okay, so I'm only going to have 1 carbon, so my number of hydrogens have to be so we have 2 times 1 plus 2, which gives you 4. So your formula is going to be CH4, which is methane. Now with ethane, again, you have now 2 carbons, so that means each carbon is going to bond with each of that carbon, and that's going to give you the opportunity to bond with 3 hydrogens, sorry. And then of course, according to the math, you are going to have C2H2 times 2 plus 2, which will give you C2H6. Okay, and we see 1, 2, 3, 4, 5, 6. Okay, and now we have propane, and of course, as that's 3, and so then that's 3 carbons that bond to each other with their added hydrogens. And remember with your chemical bonding, it doesn't mean so this will bond first. Okay, so you have your okay, let me make it in a way that we'll understand. So remember with the carbon and your valence electrons, 4. So it's not going to work in a way that this will happen first, okay? It's just how we write it. But the actual bonding is a little bit different. So for example, you have your hydrogens. It will bond to the hydrogens first, okay? So remember, it's building together. You're combining the atoms together. So you have your C. And then again, your C. But remember, automatically, it's bonding. Because remember, the whole purpose of chemical bonding is to form stable atoms. Because once your atom is stable, then the bond is formed. And remember how we break those bonds? We use energy. Okay, so just a little side note there. And so I'm emphasizing that again because it's important to connect everything. And once you connect everything in terms of your bonds, your chemicals, your chemical bonding, how important it is to know how each bond will form, especially in your chain. Okay, good. So now we have butane, which is 4, and then we have pentane, which is 5, so it all adds up. And then of course we have, okay, so those are the first 5. Good. So now as we are going over again for the rules of naming alkanes. So as we know, as I was saying, it's a single CC bond, okay? Which means it's saturated. Okay? I hope that makes sense. So remember our suffix is ane. So of course we're going to, so remember your prefix and your suffix go together. And so basically that is the most important things we need to know so far in terms of our introduction to chemical bonding. So in the next lesson, we're going to go on to alkanes and the rest of the, so we're first going to do alkanes and alkenes, and then we're going to go over the precise rules of how to name the organic compound. And as we go into the more complex organic compounds, how those rules will still apply to this. Okay, good. So if you have any questions, let me know. Remember, as I was saying this lecture, you're supposed to be taking notes. And if you have any questions as this lecture pops up, just write the questions on the end. Okay, so cool. I'll see you next time, and remember to bring your questions. Good. Okay, bye.